Hey, thank you. All right, everyone, I'm Brian Langle, CTO and co-founder of Dash. We use DynamoDB very extensively at Dash, and we're going to talk today about how we encrypt data in it. Okay, so, it's a short talk, but I want to squeeze all this in here, so we'll give a little plug and information about Dash, and then we'll dive into how we use Dynamo, why we needed to encrypt, and how we got that accomplished. Okay, so Dash, we are building a connected car platform. There's a little piece of device that your mechanic may use. It's called an OBD device, and that can plug into all cars. So we use this as well. And so you as a driver can buy one of these, plug it into your car. It'll connect to Bluetooth to your phone, and the data from your car then can be ingested into our servers and analyzed to give you insights into fuel efficiency, safety, and metrics around your driving. Okay, so at Dash, Dash actually had our 5-year startup anniversary this past July, which we were really excited about, and we've been using DynamoDB since the beginning. So back in kind of early to mid 2012, and DynamoDB was fairly new at the time. And what we've loved about DynamoDB, and I say this all the time when people ask us about our usage of it, is that it's scaled with us as a company, and it's not just the scaling in terms of normal, what people talk about in terms of scaling in terms of the amount of transactions, but it's scaled in terms of feature sets. And so, since us using it in 2012, it's added global secondary indices, local secondary indices, it's got a caching layer on top of it now, and it's done a lot of things to make our lives easier. But one of those things that it doesn't yet natively support is encryption. And so I'm going to talk about some of the use cases and why we needed to add encryption to our data at rest and what we did to accomplish that. And so for us, we have about 100 tables and tens of thousands of writes and reads per second provisioned. We basically store all our data either in Dynamo or S3, depending on some use cases, but a lot of the kind of transactional data is in DynamoDB. What we wanted to do and why we needed encryption is we needed to securely store personally identifiable information. So these are things in terms of the users, like their VIN, like their name, like their email, and their location data. And at the point we started this project about we deployed it a year ago, last August 2016, so we've been using this encryption in kind of production for a year, and I think we started this project maybe 3 months prior to kind of analyze how we were going to do this, how we're going to encrypt the data at rest, and what are the offerings and how can it be done. So the first leverage, or the first point of departure for us to get this done was a library that AWS provides in their AWS Labs. We were familiar with AWS Labs because we follow it and we've used other features that they've kind of released in AWS Labs. One was we forked their geo-querying capabilities for DynamoDB and modified that to support global secondary indices. So if you don't already, I would highly encourage you to follow the AWS Labs organization in GitHub. There's a lot of extra features, things that don't yet exist in their native services that they're kind of toying with and experimenting with and offering to the community. And so our jump-off point here is the AWS DynamoDB Encryption. It is in Java, so if you're not a Java shop, you may have to do some translation or porting or seeing how you can kind of integrate the encryption aspect into your setup. Although at the end of the day, this Java library isn't too complicated, and a lot of what can be done with it you could kind of natively do with KMS, which we'll talk about, another AWS service, and just your own language code. Okay, so this is the library I mentioned. It is written in Java. What we liked about this library is it was very extensible. And so for us, it did not necessitate us kind of querying or persisting data in a certain way. It allowed us to kind of pick how we were going to encrypt the data. And so the entry points to use your keys are, they do have a native support for AWS KMS. They allow, since it's a Java library, to use the Java native key store. which could potentially be a pain depending on your kind of setup. Are you in EC2? Are you in Lambda, etc.? And then they also, importantly, allow some custom hook. And so if you already have your key management system in some other kind of specific library that your company's written, or in some other area or tool, you can still integrate that. Another nice feature of the AWS Labs Library is the integration with DynamoDB Mapper. So if you're not familiar, DynamoDB Mapper is a way to use annotations on your kind of domain objects to kind of give you more or less automatic translation from those objects into kind of attributes that you then use to persist in query in Dynamo. But importantly for Dash and for a lot of others, they allow a different hook. Dash does not use DynamoDB Mapper. When we started using DynamoDB, this feature did not exist, and so we have our own kind of object mapper on top of DynamoDB. Okay, so how do we use it? We use it with KMS. This was very easy for us in our microservice architecture to integrate and fully manage the keys for us, as well as we have some of our processes in AWS Lambda, and so KMS was a great solution for us in terms of management of keys, and so we use AWS KMS to manage the keys for encryption in Dynamo as well. We use the DynamoDB Encryptor, which is kind of just a wrapper that lets us decorate persists and queries, so that we can say, okay, here's some encrypted data, or here's some data, let's encrypt it. It's just kind of a hook, and it more or less follows the decorator pattern. Okay, so I want to spend a little time talking about some actual applications of it. So if you're not familiar with the actual library or how one might want to do encryption, we'll talk about that, and then we'll talk into some kind of caveats or things you should be aware of. So at the highest level, what this library does, or what you would want to do, is data comes in, you want some mapping of which fields, or maybe all fields of the data, you want to encrypt. You use some kind of key management to say, look up the key for this piece of data, this is the key I'll use, let me run it through some encryption set. Maybe you're using, I don't know what you're using, elliptical curves or whatever you want to use to actually do the encryption. So then you encrypt that data, and then you store it, and then you do more or less the inverse on the way back out after querying. The thing to keep in mind, though, is, and KMS talks about this in terms of execution context, and this is how it's used in terms of Dynamo, but there's a problem with doing what I said. So it depends on your use case for encrypting data. So some of the use cases are, you want to store personally identifiable information at rest so that maybe hackers or anyone with access to your database, including your own employees, cannot query for and look at that data. Another may be regulatory reasons, right? So at Dash, one of the reasons besides just personally identifiable information being encrypted is we were making a big deployment in Europe. And in Europe, to do this deployment, we needed to have some compliance in terms of personally identifiable information, proving to them that it was encrypted at rest. And so in both of these cases, it's important to note that even if you just encrypt your data, there's a flaw. And so if you're familiar with AEAD, so authenticated encryption, associated data, KMS's execution context is here to solve this issue. And so what this issue is let's say you encrypt your data, store it in a database table. Let's say your employee, though, has access to this, or a hacker has access somehow into your table. What they can do is they can simply copy that data point. So let's say it's the user entry row, right? And so this is some opaque ID. This is a user entry row. The encrypted fields are maybe email, first name, something else important. What I could do if I had access to that, even though I couldn't necessarily unencrypt the data, I could copy that row into my own user ID, right? So I could copy the encrypted data and place it into my own user ID. Then within the app, so to say the Dash app, I could then look at my user data, and the application, the architecture, the system would unencrypt that data. And so what you need is you need the associated data with which that encryption was authenticated. And so what that means is you need to, when you're encrypting, you kind of have to sign that data such that it's impossible to unencrypt it unless you are the authenticated user. And so there's a number of different strategies to do this, but one is to say, okay, take something unique about that data row, maybe the primary key or something else that's unique for that user, and associate it into the encryption such that if you don't have that same primary key, you cannot then unencrypt the data. So this would then allow, or this would disallow anyone, including an employee or someone with privileged access to your database, to just simply copy data around and then view it in a normal context, like via the app that you give access to. Okay, and so how you do that again is with KMS, it's using this execution context. I realize here that these links are meaningless to you guys, so I should have maybe typed them out or made a bit.ly, but definitely if you are interested in this, if this is something that you're looking for your company to do, stop up after the talk and talk to me about this, or email me at Brian, BRIAN, @dash.by. Okay, so some other things to keep in mind. As soon as you then encrypt your data, and if you do it correctly and you use AAD to ensure that that data cannot be tampered with, you also have to note that there's some other things that make your life a little difficult depending on how you want to use that data. So one is querying across that encrypted data is difficult or impossible depending on what you're actually trying to do with your encryption. So for instance, if we encrypt the VIN of a vehicle, we cannot then query the VIN and say, okay, get me all the vehicles with this VIN, or give me all the users with this last name, because now that's encrypted, right? So that's obvious, but it's something to think through. So you're gonna have to, if you have that use case, think through how else do I query this data then? What are the other proxies for actually things like user support, things like this, where you may want to actually help the user by querying and seeing what's happened in the system. And location as well. So location may not be a support issue, but it may be you have features in your application, like if you drive by this region in Dash, we want to give you a notification. And so you have to then, if you're encrypting the lat long, figure out different ways of doing that query so that you can maintain individual privacy. Not every lat long is queried, but have some other way of doing that query. Now, one thing that is lacking from the library, because DynamoDB does not have native encryption support, is you have to keep in mind how you actually persist your data. So DynamoDB does have an update feature, so you can actually just update individual columns. But what can happen here though is the update will fail because a part of the encryption is taking the data fields that you're encrypting and actually making a signature of them. And so if you then do an update, what happens is that signature is invalid, right? And so let's say you want to update your first name or whatever in the application, or your email, and that's encrypted. You can't just call the update feature of DynamoDB, because what you need to do is, the way the library works, and the way you would have to probably do this if you're not using the library, is it uses another column to save kind of contextual information about your encryption, okay? And so because of that, you can't simply do an update. You'll have to kind of orchestrate that update to also update all the relevant fields, or do a select for update kind of pattern.